Hello and welcome to Nunley Math. I am your host, Aaron Nunley. I want to take a moment and thank you for joining us as we work our way through Algebra 1. We are currently in our fourth unit, an investigation of functions, the different types of functions, what a function is, what functions look like, how functions are related to one another. And we're about 2 or 3 days into this unit. We've already investigated kind of some basic definitions and some basic writing. We're going to explore those again today just as a means of review. And then we're going to try to expand on that just a little bit before we start our next lesson, which is on how the graphs of functions would look to you. Some quick review of terminology. We've said that a relation is an ordered pair or coordinate that states the relationship between two sets of information, with the first object being called the domain and the second object being called the range. We've talked about the fact that a function is a mathematical rule that assigns every member of the domain or input value to exactly one member of the range, the output value. And we've talked about how the domain has lots of different names or descriptions. The domain, the independent variable, the x-coordinate, or the input value. We have a tendency to use those interchangeably and not very carefully as math teachers, and I think sometimes that's confusing for students, but it would do you well to realize that those all basically mean the same thing. They are the number or value that gets put into some kind of a rule. And that rule processes that value, and it matches to a different value known as the range. Now, just like domain, we have multiple names that we use when talking about the range. We have the range, the dependent variable, the y-coordinate, the output value. Once again, all of those mean the same thing. But what's important is something goes into my rule, and it gets matched to something else. That's a relationship. If it's a function, the thing that goes in gets matched to exactly one item in the range. Or if you put something in, it can only possibly give you one thing out. Let's look at an example. I have a relationship here that on the left matches this set of items to this set of items. So on the left is my domain or input. On the right is my range or output. Inky goes to Ghost. Blinky matches to Ghost. Sue matches to Ghost. Clyde matches to Ghost. And Pac-Man matches to Hero. Is this, in fact, a function? Hopefully you realize that it is. The rule is each character has to match to exactly one item, and they all do. Notice that they can all match to the same character. That is not a problem as long as they each only go to one. How about this one? Is that a function? Hopefully you realize that it is not, because while Casper only goes to Ghost, and Charlie Brown only goes to Ghost, and Slimer only goes to Ghost, Space Ghost goes to Ghost and Superhero. Each item in the domain is only allowed to point to one item in the range. Now I'm going to make it a little more mathy for you now. Notice that I have a different relationship. We call this relationship J. We're not real creative in math. We try to be very efficient, so we don't give these great names. This one just happens to be a random letter that I picked, and I called it relation J. Notice that in relationship J, you have three coordinates, 2, 9, 3, 12, and 4, 16. Looking at those coordinates, 2 mapping to 9, 3 mapping to 12, and 4 matching to 16, can you identify the domain? Remember, the domain is the first item in each coordinate. So in this case, the domain is the 2, 3, and 4. Can you find the range? In this case, the range is 9, 12, and 16. Can you tell if this is or is not a function? Hopefully you realize that this is a function because 2 matches to 9 and nothing else. 3 matches to 12 and nothing else. 4 matches to 16 and nothing else. Every item in the domain matches to exactly one item in the range. I'd suggest taking a second and pausing the video and trying this with relation K. See if you can find the domain, see if you can find the range, and then once you've done that, see if you can determine if it is a function or not. I'm going to assume you've already done that, and I'm going to go ahead and walk through this. The domain is the first value, so I have 6, 2, 7, and 0. Notice I put them in order from smallest to biggest. My range is -2, -3, -2, and 1. Notice again I put them in order from smallest to biggest, and I did not list the -2 twice. Is this a function? It is a function. 6 only matches to -2, 2 only matches to -3, 7 only matches to -2, and 0 only matches to 1. Here's a few more of those. They all look slightly different from one another. I'd recommend pausing the video, seeing if you can identify whether it is a function or not. You are not expected to list the domain and range in this set. Just determine whether it is a function or not. I'm going to assume you've already done that, and let's walk through these together. Number 1 is not a function. This 5 matches to a 0 and a 10. That's a big no-no. Number 2 is a function. -4 matches to 8, -1 matches to 2, 2 matches to -4, 5 matches to -10. 3 is a function because 2 matches to 2.6, 4 matches to 5.2, 6 matches to 7.8. And 4 is not because 1/2 matches to 3 different things. What'd you think of that? How'd that go? Here's something new. Suppose I were to give this to you in graphic form, and I were to ask you to give the domain and range for each function shown. Now, a lot of people will do this with mental math, but I'm going to go ahead and walk through this slowly with you by looking at each coordinate separately. This is the coordinate 1, 3. Because it's so hard to write with my mouse, I'm not going to go ahead and put that in parentheses. This is the coordinate 2, 1. That's pretty hard to read. I have the coordinate 3, -1. I have the coordinate 4, 2. The coordinate 5, 0. And the coordinate 6, 6. And again, technically those should be in parentheses, but this is really difficult to do with the mouse, so I'm just going to let you do that on your own. My question is, can you identify the domain and the range? Well, once I've got it written in coordinate form, it should be pretty easy. The domain is this 1, 2, 3, 4, 5, and 6. This is your domain. Now, some people can just look at this and realize that your domain is actually listed here across the bottom. This has a domain value of 1, 2. I've got a coordinate here on 3. I've got a coordinate here on 4. And I've got something here on 5. And I've got something here above the 6. You could actually find your domain that way as well. What about the range? I've got -1, 0, 1, 2, 3, and 6. We can see it very easily here again if it's in coordinate form, but you could also just look here and say, what y values have dots? Well, notice there's a dot on this row, right there. There's a dot on this row. There's a dot on this row. There's a dot on this row. A dot on this row. There's nothing on the 4. There's nothing on the 5, but there is a dot on row 6. You can find the range that way as well. Over here on the right, this one's a little bit trickier. Notice how in the graph on the left, I could list coordinates if I wanted to. But what do you notice about this graph? Hopefully you realize that there's an infinite number of coordinates along this path. I have the point -2, -4. I have the point -1, -2. I have the point 0, 0. But there are also fractional or decimal values that lie in these spaces in between. And no matter how many of these I list, there's never going to be a way that I can list every single one of them because they're infinite. It would take me an infinite amount of time to do that. So instead, what I have to think about is if I were to look at my x values. My x values are those values along the x-axis. I can notice that I have something here at 3. I have something here at -3, -1, -2. There are values along the x-axis everywhere from here to here. But notice my graph stops at 1, and there are no values between 1 and 2. What I need is a method for writing that any x between -3 and 1 is going to match to a y value with this particular function. How can I express an interval from -3 to +1 as my domain? Well, if you joined us for the inequalities unit, you might remember that we can use a between language to describe that. All values of x that are between -3 and 1 will count. Notice, by the way, -3 itself does not count because it has an open circle here. That's why I did not use the equal sign. If that's confusing, you may want to go back and take a look at our inequalities unit. You might also notice some interesting notation here. This is called function notation. This says that every x will work as long as, notice it's just a vertical line, looks almost like 1/2 of an absolute value set bars, and then I give my solution. Notice that it's in braces. It's in braces. That is customary or common when giving things in function notation. We're always going to say our domain is this. Every x will work as long as, and then we're going to list some kind of a condition over here. In this case, I said the condition is I've got to be greater than 3 and smaller than 1, or I can write it with between language. I can do the same thing. There it is. I can do the same thing with my range as well. Remember, the range is what set of y values work. So when I was over here, I looked at -1 because it had a blue dot. I looked at 1 because it had a blue dot. I was trying to find which y values are actually passed or touched by my graph. Well, look here. This is the highest spot my graph reaches. This is the lowest spot my graph reaches. My graph touches every spot in between those two horizontal lines. So if I'm looking at my range, I'm saying that if I'm trying to figure out up and down where this graph goes, I would say that I could have it touch anywhere between -4 and 0. Anywhere between -4 and 0. Notice my graph never goes up here above 0. Notice my graph never goes down here below -4. It's always in between those two spaces. So let's write our range in function notation. This range is all y's as long as the y's are between -4 and 0. Notice it does touch all the way down here at -4, and it does actually touch 0 right here. That's not too bad, right? Two different ways for us to write the domain and the range when given in graph form. Here's something for you. I've got our function definition here again. I've got my domain, independent variable x-coordinate or input value that goes into a function rule and out pops the range. We've talked a little bit about how it has to match so that every item that goes into the function rule pops out a range. But suppose I tell you what the function rule is and I give you the domain or input value. Notice this is x, so it's going to be my input. Evaluate means find the value of f of x. Remember, f of x is our output. Find the value of your output if the rule is take x, multiply it by -4, and add 7. Then it says the values we want you to put in are 2 and -2. Here's how we're going to write this solving our function. If I put 2 into this rule, notice this says the output value for x. So I'm saying the output value, if I put in a 2, is equal to, I take this rule, and anywhere I see an x, I'm going to put that 2 in instead. -4 times 2 is -8 plus 7. The function rule applied to 2 is the value -1. If I wanted to list this as a coordinate, what I would do is I would say that 2 is matched to -1 using this rule. 2 is matched to -1 using this rule. Now let me point out a common error. A lot of people get confused because this looks like f times 2, and people feel like they should try and solve to get f by itself. That is not what's happening in this slide, or in this case. What this is saying, and I'm going to try and erase the entire slide here real quick. What this is saying is I have a rule called Rule F. I have a rule called Rule F, and no matter what I stick into Rule F, I'm always going to do the same thing. This says stick in a 2, and so I did. If I stick 2 into Rule F, what comes out? Well, it's a -1. I can do the same thing with -2. If I take a -2 and I stick it into Rule F, anywhere I see an x, what comes out is -4 times -2, which is 8, plus 7, which is 15. As a coordinate, I would say that Rule F matches -2 to 15. If you put in a 2 or a -2, you get a positive 15 out. Here's a couple for you to try. Find all values of the function f if the domain is 1, 2, 3, and 4. In other words, if you stick a 1 into Rule F, and then you stick a 2 into Rule F, and you stick a 3 into Rule F, and you stick a 4 into Rule F, what is going to come out? Well, we can check that. If you stick in a 1, 5 times 1 minus 3 is 2. If you stick a 2 into Rule F, you get 5 times 2 minus 3, which is 7. F of 3, if I stick a 3 into my Rule F, I get 12. And F of 4 gives me 17. Notice it asked me for the range, so I did present the range for you. That should have been a pop-up when I clicked, but it showed up there at the beginning for you. Hopefully that wasn't too big of a distraction. Notice we're doing the same thing as we did on the last slide. I'm just phrasing it slightly different here in the directions. Here's one. Find all values of function h if the domain is 2, 8, 11, and 20. Notice the rule is for h of x. The rule h says for any x, take that x times -2 and add 9. I'd recommend pausing the video real quick and trying that on your own to see if this is making sense to you, then starting the video to see where we are at. If I stick in a 2, I get a 5. If I stick in an 8, I get a -7. If I stick in an 11, I get a -13. And if I stick in a 20, I get a -31. The range is all of those values. 5, -7, -13, -31. How about this? Find P of 3, P of 10, and P of -12. Notice again, it's just a different way of writing the same thing. It says put a 3 into Rule P. Put a 10 into Rule P. Put a -12 into Rule P. I'd try that real quick. Here's what I come up with. Notice that I did not list that as a domain and a range this time because it did not ask me the question in that way. Here's one. For h of x equals 2/3 x minus 5, find the value of x for which h of x is -7. Notice the difference here. This time they asked me to find x. They said find the input or the domain when they give me the output. Usually they give us the domain and we find the range. But in this case, they've given us the output or the range. Can you find the input? All you got to do is take your function and replace h of x with a -7. Now it's just an equation you can solve. Property of equality to add 5 to both sides. To get rid of times -2/3, you multiply, or times 2/3, you multiply by the reciprocal, and there is your solution. In other words, when x is a -3, h of x is a -7. Or if you put a -3 into rule h, what comes out is -7. Why don't you try this one on your own? I'm going to assume you've already done that. I'm going to work through it pretty quickly. If you need to pause the video along the way and take a second look at it, you can certainly do that. I came up with x is -6. Notice when x is a -6, g of x is a -4. Here's the last thing I've got for you. Once again, I've repeated this idea of if any of these things go into your rule, out pops these things. Let's look at what the problem says. It says, let f of t be the outside temperature. Notice they're saying if you put t into rule f, what you get is the temperature. And notice I'm writing that out here so you can see it so you don't forget. F of t is the temperature. T hours after 6 a.m. Well, t is our input. It's going to stand for hours. And then it asks us to explain the meaning of each statement below. This says, if I put a 0 into my rule, out pops a 58. In other words, if I put 0 hours in, what pops out is 58 degrees. So 0 hours from 6 a.m. is 58 degrees, or at 6 a.m. the temperature is 58. Does that make sense? Pause the video, try that second one on your own. F of 6 equals n. If I put a 6 into the rule, what pops out is n. Or in other words, if I put 6 hours into the rule, what pops out is n degrees. At 12 p.m. or noon, the temperature is in degrees. Last one, f of 3 is less than f of 9. Remember, this is your input. In 3 hours, that temperature, f of 3, is going to be less than that temperature in 9 hours. Or the temperature at 9 a.m. is less than the temperature at 3 p.m. Hopefully this has been useful to you. We're trying to bridge that gap between domains and ranges using that function rule. We're going to start to look at specific types of functions as well as what patterns emerge from those types of functions in the next several videos. So I hope you'll join us for that. Please take the time to leave us a comment in the comment section. Please take the time to like and subscribe and turn on the notifications, especially if you're an algebra student or an algebra teacher, so that you can follow along with us as we go. As always, we do appreciate you taking the time to watch this. Best of luck to all of you guys. Take care.